talking about, now that we have all the details, we've got loops, we've got decisions, we've got selection, single sequential statements. Our programs are going to start to get bigger. And in order to do that, in order to have a program work effectively, we need to start breaking it up into pieces, okay? So what we're going to talk about, I don't think this is as difficult as loops. By the way, I'll have your, I have not had time to grade your quizzes. I'll definitely have them on Tuesday. Probably grade will be done over the weekend, okay? So we're going to be talking about what in C++ we call functions. In Java, you will call methods, okay? The names are the same, the names are different, but the idea is the same, okay? We're going to talk about two different kinds of functions, void and value returning. So that's how we'll start. And then we're going to pass data back and forth to these functions, and we call that parameters or arguments. That is all, pretty straightforward. Hopefully you did the lab yesterday where you saw how to call a function, how to return a function. The main tricky part with functions is when we pass the parameters, we have something called pass by value, pass by reference. We probably won't get to that today. But that's the little bit trickier part about dealing with functions. We're also going to talk about something called scope. And by that, we're going to talk about global variables and local variables. What do you think I mean when I talk about a global variable versus a local variable? Global means the whole program can see a variable. And we do that by declaring something before all the functions. We actually pretty much avoid global change, okay? And then local means what? What would a local variable be? In that function. So if you declare a variable within a function, it's what we call local to the function. It can only be seen there. And that's what we're going to lean towards, okay? So this is the things that we're going to talk about. The idea of breaking things into pieces is a pretty common problem-solving method. Anything we do seems very overwhelming. A lot of problems seem overwhelming to begin with. So when we tackle it, we tend to think, okay, let's worry about this part, let's worry about that part, let's worry about that part. We call this, kind of compartmentalizing or modularizing. Has anybody heard of the term modular before? In what context? In what context have you heard the term modular? Any idea what it means? Yeah. Modulo, using a modulo in math, maybe? A little bit different. That's like a piece, yeah. You're absolutely right. Has anybody heard of, yeah?
I mean, you take something apart with different pieces and rearrange it in different ways.
Have you heard of modular building, modular homes? Have you ever seen that? That's where they basically build the pieces at the factory, and then they put them all together at the site. So that's the same idea here. We're going to break things into pieces, and this allows us to solve problems. So so far, all our programs have been one module, but in reality, that's not the case. If you have millions and millions of lines of code, you have many different modules that you break it into. And we're also going to use a concept. So modularity is breaking a program into subprograms. And we're also going to do something called top-down, which means we start with general details, then we get more specific as we go along, okay? A lot of people have a tendency to get caught in the weeds. Like what kind of, if you're building a house, the first thing you don't think about is what kind of molding am I going to use? That should be a later decision. So try to keep that same idea when you're solving a problem for a program, okay? Think very general. Don't get hung up on some algorithm. You can throw that into a module or a function and worry about it later. So we want to think very high level, very general, and get more and more detail as we go along, okay? So that's what we mean by top-down design. So these two concepts go together with what we call modularity. The thing that I want you to remember that, I want you to skip to 3 here. It should be short enough to be able to understand what it does and to read and change it. It should be long enough to do what it wants to do. So basically it should be the perfect length, right? So a module one of the things that helps us with a modular function is what the name is. So if a modular function, and I can't emphasize this enough, if a function is called print menu, guess what that function should do? And nothing else, just print them in, right? So the name should correspond to what it is that that function does. So don't try to do too much, okay? You can always break it into other modules or functions. The other thing that, so this is kind of goes with this. The other thing that we're going to strive for with our functions is single entry. That's what happens by default. It's pretty hard not to have a single entry function. But I want you to remember something else as we look at some functions. Single exit. Get out in one place. Because there is a return statement that can allow you to exit in multiple places. And it's something we try to avoid. We can't always, but we try to avoid. So single entry, single exit makes a good function. Okay, and I'll show you what I mean by that as we move along. Okay, so one of the, as I mentioned, keep subdividing. You know, you may have multiple, multiple levels of functions, right? You start off, you have a main, and then you're going to need something to print a menu, and need something to do with the operations. That may have 3 functions that it calls. So do you see how you can break it into multiple modules? The idea of a black box is not the same thing as a plain black box. But if you think of a black box, when we talk about designing systems, that is basically an entity that does something that we don't know how it does it. So my television is essentially a black box. I don't know how the television works inside. I don't care. But I know how to operate it, and I know what I expect it to do for me. But the actual innards are not my concern. When you design a function, it should ultimately be a black box. Don't have some trick going on that the user should know about. Just let the user knows how to call it, the user knows what to expect.
I was going to when a function does its job, a black box.
It does its job. It doesn't have anything hidden that happens behind the scenes. Okay, the user should need to know about. If a function says that it's going to calculate the average, that's what it should do. There should be no trick. Nothing is happening beside that. And the user doesn't need to care how it happens. So that's what I mean about black box. Now this other idea, and I really want you to remember this as you move along in programming. One of the problems with programming is it takes a lot longer than you think. Okay? And I learned this lesson, I remember in college, you know how you can write it, well, allegedly, you can write an English paper and then some words do, okay? Obviously incorrect, but, we've all done that, okay? If you let this happen with programming, you are screwed, okay? Because it won't work, it won't run, okay? So one of the lessons that I learned the hard way, and one of the lessons that I think is something that probably takes with you with programming, first of all, you can't let go of the lesson. You'll just learn this someday. The program won't run. But always start with something small and keep it working, okay? And I call this a dummy module. Like you may have to write a function that calculates the factorial or something, whatever, okay? Just make a dummy module. You can even say, not yet implemented, but have it there, and then keep your program running with that module in place as in the structure, so it's still running, it's still compiling, and then you can add to it that functionality when you get to it, all right? So this is a trick that you move along to 236 and 237, and further from there, keep these dummy modules that, every day you have something working. Okay, main's working and it calls a bunch of dummy modules. The next day, you get the first dummy module working, you get it fully implemented. The other guys are still there, they're just not fully functioning. So always keep something working, okay? It's a way to keep up your program. First of all, this actually works well in industry because I've actually been in a situation where there's some guy in the corner writing 1,000 lines of code and he's working his little tail off, but he doesn't have anything running, okay? Another guy is writing 10 lines of code. He checks it, and then he goes home. The next day he writes another 10, he checks it, he goes home. By the 10th day, he knows that if he has a problem, where's the problem? The last 10. Whereas the guy who's writing all these other lines, he might have done more work, but he doesn't know where the problem is. So keep small chunks of code working, and then add to it so you don't get lost in in this terrible thing. And the other thing is if a customer drops in, because your boss says to you, the customer's coming and he wants to see what you've got. If you have a running product, it's a lot better, it's just a lot better for many reasons, right? And you may have done less work than the other guy. Always good to keep something working, even if that means using dummy modules, and then later adding the code. Does that make sense? Okay. Okay, so these are just some things as your programs get larger that help to keep your stuff more successful. I'm always a big believer that using good names, whether it be for a variable, whether it be for a function, kind of have like little rules I make for myself on how to name functions. So if I have a function that is called print page headings, I know what that function does, okay? If I have a function that's called calculate sales tax, it's evident what that does. Now, sometimes a function does more than it's hard to say, so I use the cheat word process. So process, test scores, kind of leaves it a little bit more open, if I'm doing more things in there, not misnaming what I'm doing. But validate input date, these are very clear names that you know exactly what the function is doing. You have the comments you have to do, and it lets you, it's going to be a better chance if you come back to that program 6 weeks later, you know exactly what it's doing. So again, using those good naming conventions. Now, we're already using the function. We're using the function main. Main's a function. You know how we say void main or int main? Okay, that's a function. All right, we call this the main line for the driver. Okay? There's nothing really special about main except there can only be one main. And the other thing special about main is it's the first function to run. We can't have another main, and wherever we start, that's going to be the first function. Okay? This function is going to be calling other functions. It should be not long. Your main function, in my opinion, should always have a loop. Okay? And it should almost look like a table of contents of what your program is going to do. All right? Because it may do nothing but have a loop and call other functions. That is totally fine. And we call that the main line or the driver. Okay? So we're already using a function when we talk about main.